Great. Thank you so much, Joyce. I hope my audio is okay. And I want to begin by thanking you, Joyce and Alex and Michael and Kelly, for organizing and hosting this unique and exciting boot camp. And Joyce, thank you for moderating the discussion that we're going to have today. And thank you to everyone on this Zoom for joining the talk. Let me just begin by saying a little bit more about myself to give context to the remarks that I'm going to give this morning. As Joyce mentioned, I'm a lawyer. I'm also an economist, trained at the University of Chicago and teaching at the University of Chicago. What I am not, and I think this is important context for this talk, is an expert in quantum physics or quantum social science. So I'm not even going to attempt to present ideas that are formalized in using the techniques or the mathematical apparatus of quantum physics. So for those of you here today who have a sophisticated understanding of the technique and the mathematics of quantum physics, you'll find my approach to be rooted in basic concepts rather than any of the formal methods of quantum science. Okay, so with that preface, let me say what I am going to focus on, which is to share with you some of the ways that concepts and ideas from quantum physics have influenced and sharpened my thinking about social science and the law. Now, I understand this to be a quantum social science boot camp, not a quantum law boot camp. And so my focus here is going to be about the intersection between law and economics, which is the kind of law scholarship that I do. And what I have found as I've reflected on my own just personal interest in learning about science, which has included learning a little bit about quantum physics, is reflecting on the insights from the physical sciences has given me new ways of looking at the law and new ways of thinking about economics and the ways that different approaches, different schools of thought within economics can interact with each other and can develop implications potentially for law and policy. So that's what I'm going to share with you today. And my hope is that I can identify some ways of drawing concepts from quantum science and deploying them to generate perhaps surprising or previously unrecognized ways of thinking about the law and thinking about using economics in particular to understand the law. So I hope that this will be a generative discussion and may identify, I hope, some avenues for conversation during the Q&A, as well as new possibilities for research and thinking in this area. All right, so what I'm going to do now is, let me see here. I'm going to share my screen. And so I hope everybody can see this all right. And I'll go ahead and begin. And of course, let me know if there's any issues with the video and so on. So in law and economics, one of the long-standing divides, and those of you who have dabbled at all in law and economics, you'll probably recognize this, but one of the long-standing divides, both in terms of the mindset of researchers and also their specific methodologies, both theoretical but especially empirical, has been between neoclassical economics and behavioral economics. And I see this in my students, law students, and even some law faculty, which is there's a lot of enthusiasm for behavioral law and economics, which I think is fabulous. But what I see with that enthusiasm for law and behavioral law and economics is a distrust or a skepticism of neoclassical economics and a belief that behavioral economics has refuted or disproved in some ways the basic ideas of neoclassical economics. And on the other side of the ledger, I'll say I have friends and colleagues who are very skeptical of behavioral economics. They see it as a waste of time because it has historically relied very heavily on the use of laboratory experiments that may have little real-world relevance. Now, the view that I have, and the view that I think is informed very much so by quantum ideas from quantum physics, is different from either of these views. And I think that many of the apparent contradictions or contrasts between these two approaches are superficial rather than fundamental. And in fact, these approaches, both behavioral and neoclassical, provide largely compatible and sometimes subtle and counterintuitive insights. So I'm going to talk a little bit about what I mean when I say neoclassical economics. I'm going to talk about what I mean when I say behavioral economics. And I'm going to try to connect them in a way that's informed by quantum science. The analogy that I'm going to draw is the distinction between quantum physics and Newtonian physics, quantum mechanics and Newtonian mechanics. So let me begin by highlighting some basic ideas from physics. Obviously, this is just a small slice of quantum physics, and I apologize to anyone who is a serious quantum scientist in the room. I'll probably get some things wrong, so please bear with me. But I think the basic concepts here are very useful in this context. So three ideas. As we know, we're all familiar from our grade school science courses, some of the basic concepts of Newtonian or classical mechanics: force, mass, acceleration, the distinction between energy and matter, the idea that light and sound travel in waves, and the idea that matter, unlike energy, is made up of discrete particles known as atoms. So that's classical mechanics as we know. And what's important to recognize is that although Newtonian mechanics it has largely been very successful at describing the interactions of most of the physical systems that we can see in the world, it tends to break down as we move to different scales beyond our own perception. And in particular, it breaks down when we look at the tiniest constituent pieces of our universe. And of course, that, as those of us on this in this room know, we then get to the domain of quantum mechanics. We're no longer looking at matter in the aggregate. We're looking at the individual components of matter, and that's when the world starts to look radically different. Matter behaves like energy, energy behaves like matter, particles behave like waves, waves behave like particles, or perhaps to say like is even to understate the equivalence. Two things can be in the same place at the same time, and the same thing can be in two different places at the same time. Or perhaps, again, that's not even completely capturing exactly how different the mechanics are at this scale. Now, that's what's exciting and mysterious in some ways about quantum physics. And what's exciting to me is the possibility that maybe some of these ideas have corresponding reality in social science as well. And so these are three concepts that I've thought about their application to social science, and that I think these three concepts distinguish quantum physics from Newtonian physics. And I'm going to argue they help us distinguish between what I'm going to call quantum law and economics and Newtonian law and economics. The uncertainty principle, the correspondence principle, and the quantum principle. So let me explain. The uncertainty principle. Perhaps the best known concept to people like me who are not experts in quantum mechanics is the Heisenberg uncertainty principle. And I'm not going to actually talk about the Heisenberg uncertainty principle. I'm referring to a more general uncertainty principle that also applies in the quantum context. And the general idea that I want to use as the conceptual link between physics and law and economics is the idea that it's impossible to know everything you'd like to know about a particle because the mere act of observing the particle affects the particle's behavior. So this is you've all probably seen some version of this diagram about the idea that the act of observation changes the velocity of the observed particle. Um, the process of observation requires interaction, and the interaction changes the thing being observed. All right, the second idea that I want to leverage here is the correspondence principle. And I already referred to this a moment ago. That's the idea that Newtonian mechanics, although quantum mechanics shows that its assumptions about the nature of material interactions are incorrect in important and fundamental ways, it actually does a pretty good job of describing how the world that we see and inhabit behaves. And so what the correspondence principle states is that quantum theory, if it is true about the world, should be able to generate true predictions about how the world works. And Joyce was just mentioning during the introduction, the question that comes up so often, which is how do we test theories empirically? And that's, I think, a very important question. And the correspondence principle makes the point that Newtonian mechanics at the scale of human observation generates predictions that are verified as accurate. And quantum mechanics, if it really is the foundational physics of the universe, it should generate predictions that are accurate at all scales. What that means as a very important corollary is that at the scale of human observation in the physical world, the macroscopic scale, quantum physics and Newtonian physics should generate identical, virtually identical, empirical predictions. Therefore, the correspondence principle for our purposes in the context of economics and law is that although Newtonian mechanics gets the details wrong, its assumptions about matter and energy are in fact violated in the quantum world, Newtonian mechanics remains extremely useful to real-world applications precisely because at the macroscopic scale, it generates very useful approximations of the quantum mechanical reality in which we all live. Now, the example I like to give here is that a civil engineer doesn't need to know anything about quantum mechanics in order to build a bridge. They do need to know about Newtonian mechanics to build a bridge, and even though Newtonian mechanics in some sense doesn't get the physics right. Now, of course, that's not to say that quantum mechanics is irrelevant on the macroscopic scale. As you all probably know, all of us rely on quantum mechanics every day in that we all have smartphones, and smartphone memory would not work without quantum tunneling, without an understanding of how quantum tunneling works. And so in that way, what we've learned is that Newtonian mechanics isn't obsolete. You don't need quantum mechanics to build a bridge. On the other hand, you do need quantum mechanics to build a smartphone. You can't do that with Newtonian mechanics alone. Okay, and then finally, the third principle that I wanna build on here in the context of economics is the quantum principle. The idea that matter and energy exist in discrete quantities. And the idea here is that in our ordinary experience, in the Newtonian world, we think of matter and energy as existing in quantities that can vary continuously. So what I mean by that is you can increase or decrease the amount of something or the energy level of an object continuously, smoothly, like sliding a slider up and down, rather than only discretely, like selecting a radio button. I can pour 1 cup of water, I can pour 1.5 cups, I can pour 2 cups of water. I can move a little bit faster, I can move a little bit slower. But at the subatomic scale, as we know, shifts in energy levels are discrete and not continuous. It's as if things are slipping into different energy levels or states in a discontinuous way. An atom can have 1 electron or 2 electrons, but it can't have 1.5, right? And an electron in the electron cloud around a nucleus can have certain energy states, but intermediate energy states simply cannot exist. That's where the term quantum leap comes from. So that's the basic idea of the quantum principle, is that certain physical phenomena occur only in discrete quantities or quanta. All right, so this is just to sum up the basic ideas here. The uncertainty principle, which is that measurement affects a particle's behavior. Again, this is one type of uncertainty principle. I don't want to overstate the generality of this. Secondly, the correspondence principle, the idea that Newtonian mechanics, even if it's not quite getting the physics right at the foundational level, is a very good approximation of physical behavior at the scale of human society. And the quantum principle, which is that sometimes things can only change levels in discrete chunks. Okay, so I've mentioned those things probably to most, maybe all of you. You're extremely familiar with these concepts already, so I'll just move on to talk a little bit about economics. And for the economists in the group, this will maybe be familiar as well. For those of you who are in other fields of social sciences, maybe this will be a useful perspective in terms of understanding some of the different ways that economists approach things. As Joyce mentioned, I'm from the University of Chicago, and so I wanted to put a couple UChicago faces here. My icon for neoclassical economics is Gary Becker, who I had the great privilege of being a student of. And for behavioral economics, I have Dick Thaler in the picture here, who unfortunately I've never been a student of, but they're both, I think, in important ways representative of these two approaches to thinking about economics. And I chose these pictures deliberately in the sense that I think we all think of theory and math as foundational to neoclassical economics, and I think there's a quantum physics connection there. And then behavioral economics, we have Professor Thaler looking at a tablet, at a smart device, and I think that idea that so much of behavioral economics, as well as quantum physics, is packed into that little device in terms of the way that memory is structured, but also the way that apps, for example, are designed. And that's one of the things that behavioral economics has generated a lot of insights about how people can be induced to behave in irrational ways, ways that would be irrational in neoclassical economics through the design, for example, of various apps and other software. Okay, so with that introduction, let's talk about neoclassical and behavioral economics. Now, let's begin with neoclassical economics. One of the most important but also heavily criticized foundational assumptions of neoclassical economics is the idea that what we are doing is we are modeling the rational behavior of people, that actors behave rationally, and mathematical models of human behavior. Rationality will often take the form of the assumption that actors in the model will be able to calculate the costs and benefits of anything they do with infinitely great precision at zero cognitive cost. Now, this is obviously wildly unrealistic, and these models have been criticized for this. Now, in its defense, and I'll say again, as a student of Gary Becker, I've got to defend neoclassical economics. I'll say that this strong version of rationality is not, or at least should not be, a claim about the actual mental processes of human beings. If it is, it's just wrong, and we know this. Rather, the rationality assumption in the context of neoclassical economic theory is a simplifying device that allows us to make our mathematical models simpler and more elegant in design on the assumption that at the scale of market behavior, of a market equilibrium, we're trying to figure out, do prices go up? Do prices go down? Does innovation change? Do more people go to college? Whatever the question is, at that scale, the assumption, and it's only an assumption, is that the rationality assumption won't fundamentally change the results. It might make it a little bit inaccurate, but it won't make it go in the wrong direction, for example. It won't make a prediction completely wrong. That is just an assumption, but that's what's going on. It's not intended to be a claim about the underlying truth of human cognition. Now, another fundamental idea in neoclassical economics, and I think this is a really important idea, and one that crucially I'm going to defend in a way that I'm not necessarily willing to defend the rationality assumption, but the law of demand, I think, is very fundamental to economics, and that's the basic idea here, that if the price of something goes up, people will buy less of it. I hope that sounds obvious to you. It's supposed to be obvious, but what's useful about the law of demand in economics, for those of you who maybe don't have a background, is that when we talk about price, we don't just mean the dollar amount on a price tag at a store. We mean anything that goes into the cost of acquiring or using something. Therefore, if something becomes more convenient, if something takes less time, if the quality of something goes up, but the dollar price remains the same, all of those reflect changes in the overall price of a good, not just the money price. And we expect people to respond to those prices in predictable ways. All right. And the third thing that I'll say about neoclassical economics, and I've already mentioned this, so I won't dwell on it, is the idea that it's describing markets. It's describing the aggregate behavior of individuals when they interact with each other in large groups. Now, let's turn to behavioral economics. Behavioral economics, there's a lot going on here. It's a huge field, very exciting, and I'm not even going to attempt to talk about all the ways in which it has broadened and in some ways challenged what it means to do economics. But I'll highlight a few important characteristics. Of course, behavioral economics is fundamentally the same as neoclassical economics in the sense that they're both economics. They're both asking, how do people behave in ways that are responsive to incentives that change how they interact with other people? Okay, so that's in a very stripped down sense, the question that all economists, behavioral or non-behavioral, are focused on. How do incentives change the way that people behave in society? But behavioral economics has some crucially different starting points and ending points. So one of the things that's different is it's much less theory driven than neoclassical economics, and it's largely experimentally driven. Most of the work historically and still today in behavioral economics is based on laboratory experiments. The limitation, obviously, of laboratory experiments is they're in the lab, they're not in the real world. The benefit of laboratory experiments is they allow the experimenter to impose the ceteris paribus condition, to keep all else equal and just vary one thing that allows us to draw causal inference from that change. The most obvious aspect of behavioral economics that we're probably all familiar with is its focus on cognitive biases, behavior that violates the idea of rational choice. Most famously, I think, in law and economics at least, is the idea of the endowment effect, the idea that you value something more if it's already in your possession than if it's not already in your possession. But there are other cognitive biases as well that I'm going to talk about a little bit later, including the contrast effect and the certainty effect. Now, when we talk about things like the endowment effect, we're asking ourselves, how will a person behave when they gain possession of something? So we're looking at human behavior at one by one. And so that's a crucial difference in terms of where behavioral economics begins, is it looks at the individual scale and attempts to draw inferences about how people respond to incentives by looking at that scale. All right, and that's an important distinction that I will that I'll return to. And I think, you're probably already saying, wait a minute, I see exactly where William's going with this, and you're right. So let's juxtapose the physics and the economics, and let's talk about the ways in which there kind of is a quantum economics and a Newtonian economics. So what do we see here? Newtonian mechanics breaks down when we look at the fundamental building blocks. In the same way, neoclassical economics breaks down at the scale of fundamental building blocks, in this case, individual human beings rather than subatomic particles. Quantum mechanics provides foundations for physics by looking at the nanoscale, at fundamental particles. Likewise, behavioral economics provides foundations for the study of economic behavior by looking at the nanoscale, individual people rather than market aggregates. And think about the uncertainty principle here. Measurement affects the observed particle's behavior. Well, we see this in economics as well, especially in the laboratory setting. And this is one of the big criticisms of a lot of the experimental work that's been done in the context of behavioral economics, which is just as the observation of a particle affects its behavior, the observation of a person affects their behavior. And there's a lot of concern in laboratory settings about minimizing observer effects, minimizing demand effects, and so on. In other words, ways in which the subjects of the experiment, because they know they're in an experiment, and because of the way they're being asked questions or given instructions, may respond in ways that don't reflect what they otherwise would have done outside of the lab setting. All right. So let me talk a little bit more about this quickly. Couple of examples, just quick examples of critiques of the observer effect. The way that instructions are given, the wording of instructions to participants in an endowment effect experiment can cause the endowment effect to become bigger, smaller, or even disappear. Maybe more importantly, in the grand scheme of things, is the fact that when you move from the lab to the field, sometimes behavioral effects go away. Importantly, not always, but sometimes they do. And we can talk a little bit more about that later in more detail if people are interested. Here's one of the really interesting observations from a law professor, Tess Wilkinson-Rhyme, that I think is really revealing about both the value but also the limitations of behavioral law and economics. Which is, in this study, she examined experimental subjects' willingness to breach a contract. So that's a good law and economics topic. What are the incentives that give people motivation to breach a contract? When will people breach contracts? When will they not breach contracts? And the neoclassical prediction is, well, a person will breach a contract whenever their payoff from breaching the contract is higher than their payoff from following the contract. The behavioral economics prediction is different. The behavioral economics prediction says, well, people have all sorts of cognitive biases, and they have altruistic beliefs, they have a sense of integrity and a sense of duty and reciprocity to others. And so because of things like reciprocity or guilt or the endowment effect, if you have agreed to a contract, you will refuse to breach it, even if it would be profitable to do so. So conflicting predictions, one neoclassical, one behavioral. What do we see in the lab? Well, the answer is it depends on how you think about it. The reality was, in these experiments, people would refuse to breach contracts, even when it was profitable for them to do so. That sounds like a score for behavioral law and economics, and of course it is. There's a but, there's an asterisk attached though. As the value of the breach went up, the willingness of subjects to breach the contract also went up. And this is my favorite quote. This is an actual quote from somebody who participated in the experiment as a subject. They said when giving feedback to the researchers, and betrayal, for the most part, was not worth 4 to 15 extra dollars. And think about that. If all it takes for somebody to betray a promise that they made is $15, in the real world, is that proof of the neoclassical prediction or the behavioral prediction? I think it's proof of the neoclassical prediction. It says more or less, if it's profitable, people are going to do it. I mean, 15 bucks. Okay, so that's my point, is that when you move from the lab to the field, you have to be sensitive to the limitations of the laboratory environment. And what we see in this experiment that's about contrasting neoclassical and behavioral outcomes is, to the neoclassical economist's eyes, actually support for a neoclassical concept, the law of demand. If you raise the price of honesty by making a breach more profitable, well, guess what? People are going to do less of it. That's the law of demand in a context that's maybe a little bit less obvious. Now, there's another type of uncertainty, this is more of a loose analogy, so I'm not going to dwell on it. But the reality is that when a field is driven purely by empirical research rather than theories that attempt to unify the various empirical results, what you end up with is a proliferation of results without any unifying theory that allow you to generate consistent predictions about future behavior. And as an economist, it's very important for us to have models that allow us to predict what will actually happen in the future, since we want to know what to do, what policies will work and what policies will fail. And, I just went to Wikipedia and looked up the list of cognitive biases that have been identified in the psychology and economics literatures. And it's literally hundreds of biases long. And the crazy thing is, these biases, some say people will do too much, and others say in the same circumstances people will do too little, and we don't know which effect will be greater without having a theory that explains when one effect will happen versus the other. And I think that's one of the real challenges of a field that's relatively under-theorized. Just to be clear, what I have on this slide is a partial list. There's actually more there if you just want to entertain yourself. But in all seriousness, the lessons here are basically that there are unrealistic assumptions in neoclassical economics, for example, perfect rationality. Most importantly, the unrealistic assumption of perfect rationality. But there's also unrealistic assumptions in behavioral economics that come out of a lot of the artificiality of the lab setting. And so that's something I'm going to get back to a little bit later on the importance of theory and, as I note here on this slide, field experiments and other sources of real-world data. Okay, another note about the analogy between physics and economics. And this has to do with the correspondence principle. Newtonian mechanics is wrong, but it works pretty well most of the time. That's the idea. Importantly, not all of the time. That's why we need quantum physics. Now, in economics, it's a similar parallel. Neoclassical economics is wrong. It just is. People aren't rational. But it's a good approximation at the scale of human society most of the time. And that's the claim I want to make. Most of the time, certainly not all of the time. That's why we need behavioral economics. And the key here is the same idea in physics applies in economics. What happens as you aggregate from the individual level, the atomic level, if you will, to the aggregate level? And what we see in the quantum realm is that a lot of the randomness, a lot of the counterintuitive behavior as you aggregate up to larger and larger scales starts to wash out and behave in more predictable and seemingly deterministic ways. And the same is true in economics. So I think that's an important parallel to draw. There's theory going back to the 1950s from Gary Becker that even though, yes, there are irrational people, there are irrational behaviors, but market forces, competition between those who are rational and irrational will drive the irrational out of the market. Now, that was a theoretical claim in 1957 by Gary Becker, but there's been a lot of work since then that has demonstrated that in some contexts, some, not all, in some contexts, this dynamic actually does occur in markets. And the other scale, which is not just individual to aggregate, but also time scales, short-term versus long-term. There's been some really interesting work about field policy interventions in field experiments, looking at the effect of behavioral-based interventions. For example, if we pay workers more than we need to pay them, will they reciprocate by working harder? That's a behavioral economics prediction. Neoclassical theory would say, you pay workers more, they'll just take the money. What we see in some of these studies is an interesting dynamic, which is that in the short run, there is this uptick in productivity that reflects reciprocity, that reflects behavioral economic biases working in a constructive and beneficial way. But in the long run, you start to see productivity drift back down to the pre-intervention level, which is more consistent with the neoclassical prediction of an equilibrium level of productivity. I'll mention a really interesting, I think this is very legally relevant, so I want to mention a couple of very legally specific examples of the interaction between law and these behavioral effects, endowment effects, and so on. So here's an example of, there's a paper by Jennifer Arlen and Stefan Tontrup from 2015 that looks at how people behave, how people respond to the endowment effect. And what they basically do is it's a lab experiment, and they have people flipping coins, and you know, heads you get money, tails you don't, and you have lottery tickets that determine you know, how you win. And what they did is they added a twist to this game, which was you can trade your lottery ticket for a different lottery ticket. And if you do, you get paid. You get paid to trade your lottery ticket for a new ticket. Now, from a neoclassical perspective, every single person in the experiment should trade their ticket. Why? Well, because all lottery tickets have the same chance of winning, but you get paid for trading one lottery ticket for another. That's free money. Everybody should do that. Here's the crazy thing. People didn't. 70% of experimental subjects refused to trade their lottery ticket, even though they were going to be paid to trade their lottery ticket, and even though there was literally no downside in terms of payoff. And the behavioral economist would say, well, that's obviously, that we would have predicted that. That's easy. It's the endowment effect. Once you have your lottery ticket, you don't want to give it up, even though there's no difference between it and any other lottery ticket. Now, the twist that they introduced, this is the law piece of it, that's that I think is really neat. They then added a step. They said, instead of you deciding whether or not to trade the lottery ticket, you can delegate the choice of trading the lottery ticket to another person. You can let them decide, and whatever they decide, you get to keep the profits from their decision. Now, here's what happened. 75% of people delegated that task to somebody else. And when the people were in the role of trading someone else's ticket on their behalf, there was no endowment effect. So they traded the ticket every time. And when they asked the subjects, did you expect your delegate to trade the ticket? They said yes. In other words, even though they knew that the delegate was going to do the opposite of what they would do themselves, they nonetheless chose to give the task to their delegate. Now, why am I saying this is about the law? The reason this is about the law is delegate, another word for delegate is attorney. A big part of what lawyers do in their jobs is to make decisions on behalf of clients. And one of the interesting things about legal ethics is that one of the real challenges that lawyers face is, what should I do if I want to do something that's different from what the client wants to do? Oftentimes, that's considered a conflict of interest. But I think what this experiment reveals is there are definitely situations where doing what the client wouldn't do themselves is in fact what the client wants in terms of their interests. I think I found this study to be very relevant to the law. Another example of an interesting effect here, and this is an example of on the macro level, not the micro level, the macro level, can an entire court system have a behavioral bias? Is this something where things won't wash out in the aggregate, where quantum really matters at the macro scale? A former student of mine, Adi Leibovich, she wrote a paper looking at sentencing by judges. And cases are randomly assigned to judges. She was looking at something called the contrast effect. With those of you who are, do psychology or behavioral economics are familiar with this. The idea is if I see something, two things, and if one thing is smaller, for example, the other thing is going to look bigger in comparison, right? But if the comparison item is bigger, the thing that I'm looking at will seem smaller in comparison. And so I won't judge the same object to be the same size depending on what it's next to. Okay, that's the idea of the contrast effect. It happens in like literal visual perception, but it also happens at the psychological level. And what we see here is judges that were randomly assigned cases involving serious crimes at the beginning of their term as a judge, they would later give lower sentences to mid-level crimes. In comparison, judges that at the beginning were randomly assigned low-level crimes would give higher sentences to cases involving mid-level crimes. In other words, the sentences that they gave would be lower if the contrast effect made the mid-level crime look less serious. And this difference in sentences is not small. The difference was about 25%. So this is not just a behavioral quirk. This is affecting whether or not people spend more time in jail in the real world. This is real world data using actual sentences by judges. Okay, so a couple of lessons that I want to pull out of this. One of the morals of the story here is like, look, they're kind of both right. That's what the correspondence principle says about physics, Newtonian and quantum. It's kind of true about economics as well. You don't have to choose neoclassical or behavioral. They both work in different contexts, sometimes at the same time. And as I mentioned, it's important for there to be theory to help explain why we see the patterns we see empirically. All right. Finally, the quantum principle, and this goes to the more speculative part of my talk. So this is the part of the talk that I hope you'll find interesting as maybe some provocative hypotheses and conjectures on my part that, maybe you'll say, wow, I think actually that's an idea worth pursuing, or maybe you'll explain to me why it's totally wrong. So I'm looking forward to that in the Q&A. So quantum principle, particles and energy changes occur in discrete quantities. Economics, here, this is a conjecture. This is not a claim from economics, but it's a conjecture that I have that I'm interested in thinking more about, is that cognition, effort, and attention also occur in discrete quantities. Here's a screenshot from The Simpsons, the TV show The Simpsons. I think this is hilarious. It's if you can't read it, it says Monstro Mart, where shopping is a baffling ordeal. And I can relate to this. I've been to these big box stores, and it's just overwhelming trying to figure out what to what to do at these stores. And uh, but from a neoclassical perspective, if I'm a fully rational, perfectly rational person, more choice should always be better, right? More choice should always be better. That's the neoclassical prediction. But of course, the behavioral prediction is the idea of the tyranny of choice. Too much choice is overwhelming to people. Now, what does this have to do with the quantum principle? Well, here's my conjecture is that if cognition has a quantum principle, then this kind of phenomenon is easy to explain. If there's certain chunks of attention that the human brain has to devote to a topic, and those chunks cannot be divided into half chunks. They're like electrons. You can have one electron or two electrons. You can't have 1.5 electrons. Then that means that if you have 20 choices instead of 10 choices, you can't use your 10 chunks of attention and divide them all in half and now have 20 chunks of attention. You can't divide your quanta, and so you're overwhelmed. You only have 10 chunks of attention, but now there are 20 choices. Now, how does this apply to the law and to economics and not just The Simpsons? Okay, well, think about risk regulation. This is a huge question in the area of administrative law and environmental policy, energy policy, workplace safety policy, you name it. When the regulators have to use a limited budget to reduce certain types of risks, whether it's workplace safety or environmental cleanup of toxins in the environment, or whatever it is, they have to choose what to clean up. Now, one of the things that behavioral economists have observed, and that is, in fact, empirically validated as something that regulators succumb to, is the so-called certainty effect. So imagine that regulators are choosing between the two potential risks. So risk one and risk two in this diagram. Risk one is a very low risk, but with further regulation, you can reduce it to zero. Risk two is a much higher risk. Further regulation won't eliminate the risk, but it'll reduce it by a huge amount. Okay, so that's the comparison we're looking at here is regulation, spending $10 million to regulate reduces us, 2% to zero, let's say. The other alternative is you can use that same $10 million on something else. You can reduce the risk from, say, 10% to 4%, a much bigger reduction in risk. But what the certainty effect suggests is that people will sometimes, maybe very often, prefer to eliminate the small risk rather than reduce the big risk. This is terrible policy because it means there's more people dying in the world. But as a psychological matter, we can understand why a regulator would like the idea of taking a risk to zero because of cognitive load. If I have to worry about two risks, that's twice as much worry as worrying about one risk, even if that one risk is much bigger. Okay, so that's the idea of quanta affecting how regulators make real-world decisions. Okay, now I know I'm running out of time, so I want to end quickly with some more conjectures that might be interesting to you. So where else might quanta explain phenomena in the real world? And I think, again, to kind of what Joyce mentioned earlier, are there ways to test empirically these conjectures that are inspired by quantum physics and applied to social science? Maybe. These are conjectures. I haven't thought through this, but I'm hoping maybe some of these will be interesting to you. So mandatory disclosures. My colleague Omri Ben-Shahar has written a book about how a huge regulatory aspect of regulatory policy in the United States is mandatory disclosures. We're not going to force companies to eliminate a risk, but they have to tell you about the risk. They have to disclose the risk. Every time you get, you buy a new product, right? There's some instruction manual that has like 16 pages of warnings in it, right? Well, that's required by law. As my colleague Omri shows, that doesn't affect consumer behavior at all. And maybe there's a simple explanation. You can't double the number of disclosures and expect to double the amount of safety. It's the tyranny of choice in reverse. Because there are a limited number of quanta of attention, you can't divide your attention among an ever-increasing number of disclosures. You can only pay attention to a couple. And so increasing disclosures has no beneficial effect at all. Another hypothesis, opposition to GMOs. Now, I know a lot of us, including myself, will buy stuff at the store that says no GMOs, and we feel good about ourselves because it's organic, and that's fine. But I'll say this, opposition to GMOs is terrible policy. It's terrible policy. Why? Well, because genetically modified organisms in agriculture require less water, require less pesticides, less toxic pesticides, and have higher yields in harsher climates. What that means is it lowers the price of food and makes food more accessible for the most vulnerable populations. And yet, why do people who care about poverty oppose GMOs? Not all of them, but many do. I think it's the certainty effect operating again. It's the idea that GMOs carry some small risk of monoculture and other things. And it's the idea that we can eliminate a small risk, even though we are maintaining a very large risk of perpetuating hunger. Regulatory enforcement overkill, I already gave an example of that. This is something that's happened a lot in the nuclear energy regulatory space, for example, and also in environmental regulation. So there are laws that basically require that risks be reduced to zero at very, very high cost, when money could be deployed elsewhere to reduce risks by a larger amount, but not to zero. CEO pay. What does that have to do with environmental regulation? I think the same phenomena might apply here as well. Why are people paid so much money to do a mediocre job at leading institutions? Well, it's because management requires dividing your attention across a lot of things. And it turns out doing that is really hard because of the quantum principle. And so it may just be that there are certain types of tasks that are compensated in a way that can only be rationalized by thinking in terms of quanta. Marginal returns to college. So one of the things, the important stylized facts in the economics of education is that higher education is worth it. Higher education is worth it. I don't have to tell all of you that, we're all academics, but that's what the numbers show. Here's the crazy thing. Lots of people who, according to some very good studies, lots of people who would benefit from going to college don't. And how can you explain that? What's the psychological cost that leads somebody to leave money on the table? Well, it could be, this idea that there are certain types of skills and college requires a lot of those that involve a lot of cognitive load. And so the idea that cognitive load can explain a lot of behavior that seems to be irrational from a neoclassical perspective, I think is assisted by thinking in terms of quanta. And I mentioned vaccines here again. I thought of this, I first started writing about this before the pandemic. Obviously, we've had a pandemic in the last few years. And there was very, very vocal and strident opposition to vaccines, but it's always been the case long before the last pandemic. And I think quanta apply here too. I think the story with vaccines is this. A vaccine has a very, very small risk of a seriously bad outcome, but it in fact reduces by a much greater risk by a much greater amount. But the certainty effect, I can eliminate the risk associated with vaccines, but I can't eliminate the risk associated with communicable disease, even though the vaccine dramatically reduces the risk associated with communicable disease. So I think what's nice about the quantum conjecture is it can actually take a lot of different ideas, different phenomena in law and philosophy, law and policy, excuse me, and rationalize them with a single theory. Rather than having one theory for every observation we see in the world, we can have one theory that unifies all of these different phenomena in law and policy. All right. So let me just end by saying that the neoclassical and behavioral approaches, I think one of the lessons of quantum physics for economics is that both Newtonian and quantum approaches are useful and they're complementary. And I won't dwell on this last point because I think I'm running long, so I'll stop. But importantly, it's not always the case that neoclassical economics supports free markets, so to speak, and behavioral economics supports regulation. I think when you put the two together, you often generate very surprising results about when regulation should and shouldn't be used. But I'm not going to go into that in the interest of time because I'd love to have a robust Q&A. So thank you for your time, and I look forward to discussion.
Great. Thank you so much, Professor Hubbard. And it's so interesting because so many things you are saying actually resonates with a lot of the quantum cognition decision group trying to do. Everyone working this and trying to find a more coherent paradigm for a lot of paradoxical findings and so on. And actually, this kind of changes in the contextual effects from the conditions and training and availability of cognitive capacity, like this interesting two examples you brought up, definitely is so interesting and worth looking at, maybe model. So, but before we go into this, let's look at the questions from the audience. I think more will be coming, but we already have two questions here. One is from Heather and Mahadi. Heather is asking, would love to hear more about how you see creative destruction, self-regulation evolving as quantum legal and economic theory and meeting real-world regulatory challenges emerging from generative AI, quantum computing, and so on. So it's a big question.
Wow, that is a big question. I see a note. Does Michael want to jump in at this point? Am I reading that note correctly in the chat?
Oh.
No, sorry, I don't know.
Oh, okay. Okay, no worries at all. So let me think about that for just 1 second. I probably won't have a lot to say, and here, but I'll offer what reactions I have. I think that one of the things that quantum modeling approaches, one of the great virtues that they have, and I was actually just I just saw a paper I think that kind of talks about this, is that they deal in uncertainty. They deal in probabilities, and they recognize that at the quantum level, the behavior of particles is not deterministic, but is probabilistic. And I think that one of the things that we struggle with in both law and economics is the ability to account for instability, path dependency, and randomness at the macro scale in systems. We're much more comfortable in traditionally looking at deterministic phenomena. And I think that quantum modeling techniques that bake in uncertainty about the exact state of a particle, that bake in a probability density field, right, rather than a single location or a single state, I think might be better suited for modeling processes that are involve high levels of uncertainty and instability. And I think there are some macro contexts where I think that's relevant for law and and for policy. You mentioned creative destruction. I think that's is a type of process that involves a lot of uncertainty and instability. You mentioned generative AI, right? Which is by definition, it's a probabilistic process of of generating answers. And there's a lot of scholarship now in the law saying, how can generative AI be used to assist judges in deciding cases? This is a super hot topic in law. And one of the things that I think is going to be an important question as judges start to say, hey, what is the meaning of this statute? I'm going to ask a computer what the meaning of this statute is. One of the things that judges are going to have to ask themselves is, the computer's giving me an answer that's stochastically generated. And how do we think about meaning that is stochastically generated? That is not something that lawyers are familiar with doing, or for that matter, that traditional methods in law and economics are familiar with doing. So that's a really exciting possibility there.
Thank you. So from David Orwell, and thanks for the talk. Interesting to see the link between behavior economics and law, exclamation mark. As you mentioned, the quantum economics here is behavioral economics, and it would be good to clarify for listeners, I agree, myself agree, that this is not the same as the actual field of quantum economics because it's different names. So in the journal Quantum Economics and Finance, we describe it as the application of probability based on projective geometry, also known as quantum probability, to model economics and finance. It draws on related areas such as quantum cognition, quantum game theory, quantum computing, and quantum physics. Part of it, N, is actual to provide an alternative approach to modeling behavioral effects. For example, in behavior economics, as you know, individual departure from rationality are assumed to be washed out at scale. However, in quantum economics, as they define, so they are amplified actually by the social technology known as the money system. Say, for example, the greater financial crisis. So the idea you mentioned of chunk of attention is a great match, though. That's interesting.
Yeah, so I think, point well taken. I do want to be clear that the way that I'm using quantum concepts is analogical rather than as a matter of technique. And so, yes, quantum economics is using the methods of quantum theory as technique. So I want to disclaim any attempt to explain or describe quantum economics or the kind of work that would be published in the Journal of Economics and Finance. I'm glad that you like the chunks of attention idea, because I do think that that's an example of something that probably could be modeled formally using genuine quantum economic methods, beyond my skill level, certainly, but I do see that as an intriguing possibility.
Yes, thank you. I think maybe it's a quick follow-up is that it's so interesting to compare the neoclassical and the behavior with so I like how you compare the like in the economics traditions about how the data and experiment are driven to require for those kind of very puzzling results needs a kind of new description and kind of different way of theorizing. For those of us working in the decision and cognitive models of those kind of paradoxical findings, actually trying to make exact formalism of quantum theory. So may not people have different stands about whether it's quantum like reality or quantum brain or but most of us working with the computational models really just using the formalism, theorizing those kind of process. And I think it's really consistent with what you were saying about why so is that the limited attention of human cognitive capacity of people be able to only sequentially process certain information. So it's very contextualized. So I think this is a really great time you move to the panel because I see Professor Emmanuel Pathos has a handout, and he has a lot of nice review paper, recent one, updating a lot of information. So Emmanuel.
Hello, William. Thank you very much for this talk. It was really interesting. So in terms of quantum cognition, at least, it's interesting that people have taken advantage of all quantum effects apart from discreteness. and as how it's really fascinating to see some proposals for how this might be relevant in behavioral economics modeling. So I've got to sort of a couple of related thoughts. One of them is that generally speaking, the question of the internal scale people are using for judgments is a complete unknown. So, for example, in decision research, people would typically employ confidence scales of 1 to 7 or 1 to 20 or 1 to 100, right? And it's almost invariably a coin toss as to whether the granularity of the response scale maps onto the internal scale for these judgments. If I'm asking you to make a confidence judgment, and I tell you, well, can you tell me, say, how confident you are that, I don't know, things will go well in the next year, and I should do this on a rating of 1 to 10. Well, we assume this rating scale maps to some internal confidence scale, but we have no idea. And something that you said earlier, so I suppose that's kind of something that relates to the idea that maybe some behavioral observables are discrete, because if that's the case, then it should be possible to identify more natural internal scales, that is, scales that map better to the judgments we offer. Now, a kind of related point that going back to another thing you said is that the cost. I mean, if we ask for more precise judgment, say if I'm asking you, what do you think is the risk of crossing the road? And you say, well, I think I'm going to be all right. And then if I ask you to be more precise about this cost, the effort of extra precision has a behavioral cost, right? And you're completely right about this. And in fact, we tried to set up a study on this a while back, but it never quite went off the ground. And we think that this is likely to be a function of the utility for the different outcomes. So for example, if I'm asked to cross the road and I want to judge the probability that I'm going to be safe, then it kind of pays off to be, to have extra precision in my probability that I'm going to be safe, right? But also it may be a function of the probability range as well. So for example, if I'm close to say 0.9 or 0.1, maybe the marginal benefits of getting extra precision may not be that great. But if I'm close to 0.5 and I want something to decide me one way or the other, maybe it kind of makes a bit more sense to seek precision. So there are a couple of really interesting issues there, and I'm really glad you touched on them, because as far as I know, there's essentially no research on these questions. That is, what's the cost of precision and how either utility or the probability themselves affect bias as to seek for more precision than another one. And the third related, so these are kind of like 3 points that they're all loosely related, and they're not really questions. I'm just highlighting, picking up some threads of what you said, which I found really interesting. So the final kind of thread like this is that when we talk about precision and discreteness, right, possible discreteness in say the judgments we make, well, it's also possible that in some cases there is a quantitative, trying to achieve a quantitative sense of our judgments is inaccurate. That is, it's possible that in some cases probabilities are just vague, or our perception of utility is vague. So for example, if I'm asking you, well, what do you think is the probability, you're going to find a particular thing in this big monster story you're talking about. You may say, well, I think it's high, but if I ask you to be more precise, it could be with just kind of generating noise.
Right.
And Richard Schifrin has had a paper on that. He's been advocating this idea for a while, that in some cases our probabilities are vague. That is, it's kind of meaningless to try to assign precise quantitative expressions to all probability judgments or to all utility judgments. Now, in principle, one would have thought that can be related to the quantum formalism, because in the quantum realm, there are these states which can be inherently vague. They're about potentialities rather than classical uncertain mixtures, but we've not managed to do that yet. So anyway, I just kind of sorry for the long comment, but I mean, there's very, very original set of ideas there. To summarize, I suppose, the three things I'd say is that, yeah, discreteness is a very interesting property of quantum theory. As far as I know, nobody has really tried to test that or exploit it in quantum cognition. Second point is that, yes, there is a question of the precision of internal scales and how we sort of balance the cost versus the benefit. And again, that is a research area, waiting to be started by somebody, I think. And the final one is that it's possible that in some cases, together with the strictness, or possible instead of strictness, with just a vagueness. I mean, it's just there is just like that, just these vague judgments that we should not be looking to quantify further, at least with classical tools. So anyway, yeah, thank you.
Great, thank you.
Thank you. So, okay, next one is actually touches on maybe the empirical testing part of it already. So from Samara Shaz, thank you for this talk. On your point of cognition have discrete levels in decision making, what do you see as possible variables that I guess can be manipulated, like number of choices, number of previous decision made that day, number of choices for other items? In other words, do you think it's a number of decisions we can make, or the amount of energy, I guess like attention capacity, we can put into decision making?
Yeah, so this is all just a conjecture on my part, and I think ultimately, kind of Joyce, to your point about the empirical piece of it, and to Emmanuel's point about the need to kind of connect these different ideas about discreteness and vagueness, and the different ways in which people allocate attention and energy to these decisions. So I think ultimately those are going to be questions that are going to have to be answered empirically. I will say that I think the fundamental claim that the basic idea that I think is interesting to me here is that we should think not just in terms of how much energy do we put into decision making. In other words, how much do I invest in the question of getting a more precise estimate of risk, or how much energy do I devote to decision one versus decision two, but also to build in this idea that there's a minimum discrete amount of energy required to make any decision, no matter how trivial, and there's a minimum amount of cognitive load that comes with a question being open in one's mind, maybe would be a way to think about it. So and so it's not just, so having 20 really small things to worry about is going to impose more load on your mind than having one really big thing to worry about, even if the consequences of that one really big thing are much bigger, are much more serious than the consequences of the 20 small things. Because if you were to give the small things as much attention as they deserved, so to speak, from a pure, let's maximize the accuracy weighted by the significance of the choice, kind of in the way that Emmanuel was describing, if we were to do that perfectly in kind of the neoclassical way, we would give those small things very, very little attention. But because we can't give them half an electron worth of attention, again, just metaphorically speaking, we can't give them less than the minimum quanta of energy. We end up using all of our cognitive load, paying too much attention because we can't subdivide our attention to these things, and that leaves insufficient cognitive load to address the bigger question that actually deserves more attention. Now, what that means is there's a certain rationality to the irrational behavior of the certainty effect. In other words, if we say, look, we're going to spend all this money reducing a risk from 1% to 0%, instead of reducing this other risk from 10% to 4%, that's bad policy from the perspective of the actual amount of risk in the world. But if the policymaker then has one less thing to allocate mental resources to, it's possible that the quality of their decision making subsequently will be higher. because they are now able to optimize properly their attention across issues. And so that's the sense in which we might think that that thinking in terms of attention having this minimum quanta that's required could affect, policymaking in kind of interesting and counterintuitive ways. I'm not answering, to be clear, your question of is it how many decisions in a day, how many decisions at one time? Is 20 too many? Is 5 too many? What counts as a decision? Does putting toothpaste on your toothbrush count as a decision? Probably not. But where do you draw the line between what counts as a choice and what doesn't? I'm only at the point of a thought experiment. I haven't gotten to the point of saying how would we design to start in the laboratory? How would we design a laboratory experiment where what we're doing is we're asking people to complete tasks and we're varying the cognitive load based on the number of different things they have to have in mind. And we're asking, how are they optimizing? Are they choosing to just knock things off the list, even if they're knocking off things that actually have lower payoffs than partially completing something that has a higher payoff? That would be consistent with this idea of sort of rational irrationality, right? We're being rational about our own cognitive limitations. We're trying to, that would be the certainty effect. But then to say, if you double the complexity of a single task versus having doubling the number of tasks, is that look the same in the lab, or do people behave differently when it's one task that's more complex versus two tasks that are less complex? If there's a difference there, then that suggests that maybe this quantum idea is actually operative. So, again, I'm just at the conceptual stage, but but your question prompts me to at least, speculate a little bit about how you would actually design a laboratory experiment, for example, to identify these effects and to try to even quantify them a little bit.
Thank you very much. Maybe I can quickly chime in to share some experience from the labs we are working with. So it's really maybe also what makes working with the humans a much more interesting and challenging than maybe working with the particles. So for example, let me make an example. Some more recent work we did in the lab with centipede again, which is the based on the backward induction and weakness of the subgame perfect Nash equilibrium. People should with the shared rationality should keep the part because they are multiple player, two-player, multiple stage again. So they should rational choice should keep the part at the beginning, but in reality people don't. Most people don't. But there are people who do, like the chess masters, because they are so good, so practical. The capacity is so large. So for them, in the data, we didn't work with them, but from the literature, this population who has the capacity can be rational in the neoclassical sense and keep the part at the beginning. But we twisted those again. Actually, this relates to William was chatting this very interesting phenomenon about the delegation change the endowment effects. And what we manipulated was changing this traditional centipede again, but make the player also think what other player would do. So kind of implement some theory of mind in this multiple player game theory kind of situation. And we found very interesting data. But I wanted to just summarize to say it's quite complex, so way complex, like William was chatting as Emmanuel was chatting. I think it's individual based and based on many other factors determining the person at the time. Some of the quantum rules that wouldn't change, maybe with the particles now would change, much more complex in the human situation. That's really. So we'll maybe chat more in the afternoon, like in the empirical testing session, we can have a roundtable discussion on this. So now, next is Leslie Hilama. Excellent presentation. The certainty effect, quantum conjecture is interesting when applied to complex societal issues such as the opioid crisis, which is irrational probably. People, experts seem to want to work on the smaller or no elements of the problem, not look at the larger complex systems, while they could have an even larger impact. Have you seen any case studies that have helped mitigate the impact of the certainty effect?
Yeah, that's a great question. As a matter of policy, how do we mitigate these effects? I don't, it's not something I've looked into, so I won't say much about it. I guess I'll just relate it back to the delegation observation that Joyce just referred to, which is to the extent that decision making can be placed in the hands of somebody who doesn't have psychological investment, certain types of effects can be mitigated, like the endowment effect. But for the certainty effect, if it really is about cognitive load, then the only way to deal with that is through subdivision of tasks, right? And I think one of the things that we see in academia, we see this in government regulation, is a proliferation of specialization that I think just reflects the fact that as things become more complex, specialization is required in order to maintain a manageable cognitive load. But kind of to the first part of the question, if in order to maintain cognitive load, people are specializing in narrower and narrower parts of a problem, how do we actually look at the problem in a holistic way? And I think that's, you know, that remains the question that's created by increasing complexity. And I don't have a good answer to that, but I think that structurally, the question of design is, are there ways of using, and this goes to the question about technology and generative AI, for example, are there ways of using technology to filter topics? Because technology isn't subject necessarily to the quantum principle in terms of the amount of energy devoted to different topics, the way that the human brain may be. And so there may be use of technological intermediaries between people or delegates in order to filter information upward for the purposes of systemic policy.
Yeah, thank you. I think we are right at a good time, and I'm not sure, William, will you have time to attend 1 to 2 o'clock? Kind of you and Emmanuel Pathios be able to attend a question session, or I can, yeah, 1 to 2 o'clock.
Eastern time?
Yes, correct.
To 2 o'clock. The rest of the day is pretty full, actually. So, if
I
something gets
imagine.
canceled, I will hop on. But
Yeah. So
yeah,
there are 4 more questions here. Maybe we can let's go. Let me see a few more. Maybe next one, I will email the rest to you.
Yeah. So you know,
Okay.
I just took a quick look at them, and I will say that I won't. I don't have any. I won't be able to offer any wisdom about neoclassical versus Keynesian macroeconomics. I'm kind of a microeconomist myself, so I'll just stay away from that. It's a super interesting question. I just don't have a lot of insight to you know to offer there. There's a question about the observer effect. There's more to say there. There's lots more to say there. I will say there's a good literature on observer effects and demand effects in psychology and behavioral economics. So there's a lot out there that answers the question better than I could anyway. So I'll set that one aside as well. And then there's a point about game theory. How does game theory fit into this? Great question. My only comment there is I treat game theory as a branch of neoclassical economics. It's not price theory, that's true, and I agree with you about that. But it's not behavioral economics, at least not formal game theory that relies on perfectly rational actors is not. And so I would include game theory in the comments that I made about neoclassical economics. But I don't have a good answer to the other part of the question, which is how to think about quantum approaches to game theory, which I think is a super interesting question, but I'll have to just confess that I don't have good answers for that.